Welcome to the video on the regression equation. So your regression equation for x on y is going to be x equals c plus dy. So previously we learned about the regression equation for y on x. So this is going to be the other way around where we find x using y. So d in this case is the change in x over the change in y, and c is the x value when y is 0. This line can be used to predict x using y, like I mentioned, and making a prediction of y from the value of x is not always reliable when using an x on y line. In that case, you'd want to use a y on x line. So to calculate your regression equation, in stat, you'll hit edit, and then you'll enter the data into L1, your x values, and then your y values into L2, and then you'll hit stat, calc, linreg, ax plus b. So this is the same as our other regression equation. But for your x list, you're going to put L2, and for your y list, you'll put L1. And then you'll hit calculate. So here we have a table where it's temperature versus ice cream cones purchased. You'd enter your data, and then your x list is L2 and your y list is L1. So to change the lists, you'll click second, stat, and then select the correct list that you want to use. So then your x on y equation will be x equals ay plus b. So your equation would be x equals a, which is 0.304, times y plus b, 1.024. So this equation, you're using y to find x. So here we have our first IB practice question where the calculator is allowed. It says a survey was done to determine the number of hours someone spends on electronics each day versus his or her self-rated happiness on a scale of 1 to 10. Write a regression equation for the hours versus happiness and an equation for happiness versus hours. Then predict how many hours someone uses technology if they rate their happiness a 7. So we'll start by entering our data into our calculator. This will be L1 and this will be L2. So our first equation, we'll do our hours versus happiness. So our input is going to be hours and our output will be happiness. So for our linear regression, our x values will be L1 and our y values will be L2. So our happiness will equal negative 0.429 times the number of hours on electronics, so times electronics, plus 8.505. So we can find that under our linear regression when we use L1 for x and L2 for y. So now for our equation of happiness versus hours, we'll use L2 for our x list and L1 for our y list. So then we'll get that the number of hours on electronics is equal to negative 1.3 times their happiness rating plus 13.633. So here are our two equations. We want to define our variables. So H will be happiness. And E will be number of hours on electronics. So finally, we need to predict how many hours someone uses technology if they rate their happiness a 7. So they rate their happiness a 7, so our input is happiness, so we need to use the second equation. So E equals negative 1.3 times 7 plus 13.633. So this would be 4.533. So someone who rates their happiness a 7 likely uses electronics 4.5 hours. So these would be your answers. These equations with their definitions as well as this part down here. So here we have our second IB practice question. It says a restaurant randomly selects tables and records the number of people at the table and the total bill. A, write the regression equation in the form x equals c plus dy. So we'll start by entering these into our calculator as L1 and L2. And then we'll do second calc linear regression, where L1 will be our y values and L2 will be our x values. Then when we hit enter, we can say that x equals, our c here is going to be our b value from our linear regression. So it'll be 0.259 plus our d here is going to be our a in our linear regression. So 0.0456y. So here's our answer to part A. For part B, it says, what does the constant represent in this situation? So our constant is 0.259. So our number of people is x and our total bill is y, even though we entered it differently here. That's just how we create the equation. So our constant is when y is 0, when the total bill is 0, then the number of people is 0.259. So when the bill is $0, the table likely has 0.259 people. So this wouldn't make sense in real life because you can't have part of a person, and also the bill is not going to be $0 if there aren't any people there. So really the constant should be 0, but your line of best fit shows that it's not. So part C says, what does the coefficient in front of the y represent? So the number in front of the y is change in x over change in y. So change in number of people over change in dollars. So this means that for every 0.0456 people, the total bill goes up $1. So what this means is that your total bill will go up quite a bit if you just go up one person because it's a 0.0456. Part D says how many people are most likely at a table where the total bill is $100. So that means our y value is $100. So it would be x equals 0.259 plus 0.0456 times 100, which equals 4.819. So there's probably 5 people at a table if the bill is $100. So for this one, we rounded to the nearest person because you really can't have a decimal amount of a person. So in summary, the regression line of x on y is x equals c plus dy and can be used to predict x using y. To calculate the regression line of x on y, you hit stat edit and enter the data. Then you hit stat calc linear regression and put x in for L2 and y for L1, and then hit calculate, and your x on y equation will be x equals that a value times y plus b. That's all for this video. Thank you for watching.